Hello, Algebra 1 students. We are now in Unit 6, our quadratic function unit. So this unit, we're going to be learning all about quadratic functions, what they look like. We're going to learn a little bit about solving some x-intercepts. So let's go have some fun. So today we're going to talk about quadratic functions and understanding the shape. So we have provided you some shapes. We are going to explain all the various pieces of the shape. You're going to have to be able to identify all these pieces. So today's essential question says, what are the characteristics of the graph of a parabola? So you should be able to answer this by the end. So this unit is all about quadratic equations and the graphs that these equations plot. We call the shape of these graphs a parabola. Hence it was in the essential question. But just to reemphasize it, right? The parabolas. There are a few ways we can write quadratic equations for this, but for this year, our focus is going to be on standard form, right? So standard form looks like this. It should look vaguely familiar because it's y equals ax squared plus bx plus c, right? Standard form for our factoring in last unit, right? It's the same, looks the same. Quadratic, standard form for quadratics is ax squared plus bx plus c. We're just adding the y in now because we need to graph. It's a function now. It's just like when we did linears as y equals mx plus b. Same idea. All right. That's not standard form, but you know what I mean. So here we have a couple of parabolas. I'm going to tell you the equations of these just so you have it as a reference here. So this red parabola is y equals negative x squared plus 2x plus 3. So y equals negative 2x squared plus 2x plus 3. The blue one over here, it looks very similar, and the shapes of these parabolas look very similar if you look at them. This is y equals x squared plus 2x minus 3. So the c term is different for these two, and the a term is different. The middle term in the b term in the middle happens to be the same. All right, so these are just the equations as a reference point. Let's talk vertex first. So the vertex of a parabola is one of the most important points when we go to start graphing them. We're not going to graph them from scratch this year, but when you do graph them in Algebra 2, you're going to have to find the vertex first, usually. So the vertex is the lowest or highest point on the graph. So lowest or highest point on parabola. I'm going to call it the parabola to keep re-emphasizing the vocab. All right, so if I look at my red parabola up here, let's identify the vertex. So the vertex is this point right here at the top. I'm drawing the little dot right there. So that means the ordered pair for that point is over 1 up 4. So 1, 4 is the vertex of this parabola. Now, when we talk vertex, we also like to define the type of point it is. So if the vertex is at the top of a parabola, we say a parabola has a maximum value. So I'm going to write that down here, maximum value. So that red parabola has a max. Like we abbreviate usually saying a max because the vertex is at the top. It can't go any higher than that max value. Now let's look at the blue one. The blue parabola has a point down here. So the vertex is down there. So that vertex is over negative 1 down 4. So negative 1, negative 4 is the vertex. Since the vertex is at the bottom of the parabola, we say it has a minimum value, or min for short. We usually say max and min. Does the vertex have a max, or does the parabola have a max, or does the parabola have a min? Those are what we typically you'll hear. All right, so that's vertex, the point at the top or the bottom of the parabola, one of the key points for parabolas. Now let's talk axis of symmetry. Axis of symmetry is the vertical line that goes dashed and divides the parabola into mirror images, and this goes through the vertex. So I'm going to draw it right now on the red one. So if you're up here with me looking at the red parabola, it is a dashed line. We draw it dashed. Kind of an imaginary line that goes through the vertex that if we fold that parabola over top of itself, all of the points on the right are going to match up exactly to the points on the left. It's a mirror image. So let's go ahead and write down what it is first. So it's a vertical line. It's always vertical. And we always draw it dashed. It's dashed because it doesn't really exist. The parabola is the graph. The dashed line is kind of it's a place for us to be able, when we do graphing and stuff, we need that dashed line there. So we draw it dashed to help us. That divides. So divides the parabola into mirror images. And then I'm going to make a note that it goes through the vertex. It's always goes through the vertex. All right, so it's the vertical line that is dashed that divides the parabola into mirror images and goes to the vertex. So I drew it on the red one. I'm going to also draw it now on the blue one. All right, so if you printed these notes, you should draw it as well. If you did not print out these notes and you're doing them on your own, then make sure you're sketching a little parabola and sketching, at least sketch the red or the blue. You probably don't have to sketch them both if you're sketching, but make sure that way you can clearly see what it is that the axis symmetry is that dashed line that's going through the parabola. You want to make sure you can see that. All right, so let's talk about the red one first. So the red one. Right? It is a vertical line, so we need to write the equation of a line. The equation of a vertical line is always x equals wherever that line crosses the x-axis. So that red parabola's axis of symmetry crosses the x-axis at 1. So x equals 1 is the red parabola's axis of symmetry. The blue one, again, always x equals, axis of symmetry is not a number, it is in a line. So you need to write the equation of a line. So it's x equals, in this case, it goes through -1. Right? And so let's make a note here that we write the equation of the line, which means x equals some number, right? It's always going to be a number here. And this number is always the x coordinate of the vertex because that's where it's going through. X coordinate of vertex. So if you know the vertex of a quadratic function or of a parabola, then you should be able to tell me the axis of symmetry right away because it is where it goes through that x coordinate, right? The x coordinate is what's going to cross the x-axis, which gives us the equation of the line. All right, so that's vertex and axis of symmetry. Let's go on to the next page. All right, so I have the same graphs up here. I put them on the second page so we have them as a reference point again. Now let's talk x-intercepts. So x-intercepts, first I'm going to give you some other words that we use for x-intercepts. We call x-intercepts, I'm going to put them in parentheses here, we call them the roots, which you'll see here in our third thing of notes for today. We call them solutions to the quadratic. We also call them sometimes the zeros. Kind of depends on, that's a Z, sorry. Depends on what you are talking about in terms of the parabola, which of these words that we would use. They all reference, for quadratics, the x-intercept. An x-intercept is just where the parabola crosses the x-axis. So where parabola crosses x-axis, right? So it's where the parabola crosses the x-axis is the x-intercept. So for the red one, we have a point here looking at the x-axis, right? This is my x-axis, and we have a point here where we cross that x-axis. So just looking at these parabolas, we can identify them. We are going to learn how to solve these as well, this unit, right? So the red, my x-intercept is -1, comma, 0, and 3 comma 0. There's two of them. It crosses the x-axis in two places. And then the blue one also has x-intercepts. So I see an x-intercept here, and I see an x-intercept there. So for the blue parabola, my x-intercepts are -3, 0, comma, issues with commas in the stylus, and 1 comma 0, right? Those are the two x-intercepts. Now these two parabolas both have two x-intercepts. When we're talking about solutions to a quadratic, there are three possible types of parabolas. So let's go ahead and I'm going to list those down here. This is important, one of those important conceptual things to understand, right? So two solutions is what we have in our parabolas that we have graphed. So I'm going to write two solutions, and then I'm going to sketch here a little x and y axis here, and then I'm going to change to green, and I'm going to draw a parabola. So an example of two solutions would be this, right? Here's an example of two solutions. There's one solution, two solutions, right? Crossing the x-axis, right? It's all about the x-axis in two places. When we're talking about quadratics, quadratics can also have one solution. So one solution, so I'll sketch a little, just a quick little sketch here, right? Here's my x-axis. Change over here to green. If it's one solution, that means, all the way down here, that the parabola's vertex is on the x-axis, right? It touches in one place. There's only one vertex in a parabola. Every other point in a parabola, there's one on the right, one on the left. But the vertex is the one point up there in the top or in the bottom. So, and it could be a bottom one too, if you want to draw that in your note. Ugh, I can't tell my stylus from touching here. All right, so it could be going up or it could be going down, but there's only one point that the parabola touches the x-axis. That is one solution. It only has one place, and that's the vertex and the x-intercepts are the same. All right, so that's going to be the exact same point. Then we can also have what we call no real solutions. No real solutions. You need the word real in here because there are what we call imaginary solutions that you will learn about in Algebra 2. Right, but there's no real solutions, right? This is zero solutions, so we call it no real solutions. And no real solutions are parabolas that look something like this, right? Where the vertex is above the x-axis and it's going up, or the vertex is below the x-axis and it's going down, right? It never touches the x-axis. So it starts somewhere above, the minimum point somewhere above and it goes up, or it's somewhere the minimum point's below the x-axis and it goes down. So you can have two solutions, one solution, no real solution. Real is kind of important with this because there are, as I said, excuse me, I just burped. There are imaginary solutions that we're not going to worry about this year. All right, so those are x-intercepts, right? We also have y-intercepts, right? Y-intercepts don't have any special names or any of that, and they're just where the parabola, where parabola crosses the y-axis. So crosses the y-axis, right? So the y-intercepts are where the parabola crosses the y-axis. Sorry if those words are harder to read. Right, so identifying, I gave us graphs so we could clearly, easily see these points. Right, so the y-intercept is this point on the red one right up here, right, where we cross that y-axis. So for the red parabola, that y-intercept is when x is 0, y is 3. Because remember, x is always 0 for any y-intercept. And then for the blue one, looking here, my y-axis, my blue one is down here. So the blue y-intercept is over 0, down 1, 2, 3. So 0, -3. And it's kind of important to note here that every parabola has one y-intercept. So every parabola has one y-intercept. So every parabola has one y-intercept. Right? It's exactly 1. Right? If you can't see it on a graph, like if you're looking at a graph and you can't see the y-intercept on the graph, then you'd have to plug in 0 for x and solve for y in your equation to calculate it, right? It's always that y-intercept. If you remember this equation up here, if I go back here to my blue one, right? My equation for my blue parabola was y equals x squared plus 2x, right? Was it plus 2x? X squared plus 2x minus 3. All right, so if you plug in x for 0 and solve for y, you would get y is -3, right? Which is the point 0, -3. So it makes sense with that equation. All right, now let's talk domain and range. Domain. If you remember domain back from our linear unit, the domain are the x values. Now, on my graph here, I did not get the arrows in here. The program I used to create these graphs didn't draw the arrows in, but really these parabolas have arrows. They go on to infinity. So the domain, as the parabola goes on, it gets wider and wider and wider. So that means eventually it's going to get so wide that it's going to get all of the x values. So the domain, just like, hopefully this sounds familiar with regards to linear, right? The domain is all real numbers for all parabolas. Parabolas, right? The domain is always all real numbers because that's always going to widen, 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 and eventually get all of the x's. So the domain is all real numbers here for all of these, this entire unit. The range, on the other hand, is not quite the same. So I'm going to go ahead and let's see, so I can see right, the range, if you remember, is the y values. Now, if we're looking at our red parabola up here, right, the y values, it's not going to be all real numbers. So the range is always going to be represented by an inequality. All right, so the range is represented by an inequality. So if I look at my red parabola up here, right, the vertex, that top point, it doesn't go above that top point. So if I'm looking, let me change this over to red here. Red, the range of my red is going to be y is less than or equal to, it goes up 4, right? So less than or equal to 4. That is the range because it doesn't go any higher than 4, right? If we're up here at 5, we're not on the parabola anymore, right? We're at 4 is where we top off. In contrast, the blue has a low point, right? It had a minimum value. So the parabola doesn't get any lower than -4. So that means y is greater than or equal to -4. So if your parabola has a min, that means that's the lowest value, then the range is going to be bigger than than that value. And if you notice here, these are the y/coordinate. These are the y-coordinate of the vertex. Right? The how high or how low also ties back to that vertex. So range ties back to vertex. So it's always an inequality, and so just look at the parabola. If you don't remember whether it goes up or down, look at your parabola. If your parabola is going down, then all the values have to be less than. If the parabola is going up, then all the values have to be greater than. Okay? Last thing we need to talk about is increasing and decreasing. We talked about increasing and decreasing for linear stuff, right? If we were, remember when we were going from left to right and whether we were increasing constant or decreasing. This is the same idea now, just for a parabola. Now the thing with a parabola is that, am I still in the block? Okay, let me make it a little bit bigger here. That for a parabola, every parabola, I always got to sound it out. Both increases and decreases in relation to the vertex. So every parabola is both increasing and decreasing. What we need to figure out is which side of the vertex it is increasing or decreasing. That's kind of the key here. So every parabola both increases and decreases in relation, there's an S here, to the vertex. Right, so important, I'm going to write up here right and left in case we're not good with our right and our left, because this is how we usually ask these questions. What we usually ask you is what is happening to the right of the vertex and what is happening to the left of the vertex. So let's do the red one first. So if I'm looking at the red one here and we say right of vertex, then we need to figure out if it's increasing or decreasing. Maybe I'll draw an arrow. So what I like to tell my students is to think of yourself as an ant on your parabola, right? So I'm on the red parabola here at the vertex. If we're to the right of the vertex, that means that we are going away from the vertex, right? That means we're going down the hill. So this side is decreasing, right? So we would say to the right of the vertex, this parabola is decreasing. Because if we were an ant at the vertex, to the right of the vertex, we're going down that red one, right? To the left of the vertex, right? If we're on the left of the vertex, we're not to the vertex yet, right? So that means that we would be increasing. I'm going to write it on the parabola too as well, right? But if we're on this side, that means we're going up towards the vertex. So that means it's increasing. So the red one, to the right of the vertex, we're decreasing. To the left of the vertex, we're increasing. Right? That's a parabola that's going down. Let's look at the blue parabola, and we'll do the same thing. So the blue parabola, if we're starting with right of the vertex again. So right of vertex. So if we're on the blue parabola, the vertex is right here, right? And we're going to the right of the vertex. That means we're going this one here. That means we're going up, right? Because we're at the bottom on the blue parabola. So that means that on the right of the vertex, we are increasing. Because we're crawling back up the parabola. So everything is in relation to the vertex. The left of the vertex here, right? Left of the vertex, that means that we are, the blue starts, let me bring it down here a little bit. The blue starts up here and it's going down towards the vertex. So that means that we are decreasing. Right? Cannot read that very well, huh? Let me write that again. Try not to write. Can't write small up here for some reason. Decrease. That's an E, right? So it is decreasing. Right, so left of the vertex, we're going down towards the vertex at the bottom, we're decreasing. Once we get to the bottom, we turn around and crawl back up, now we're increasing. So that's increasing and decreasing. So that's the key things that you need to know about the parabola. So you kind of got to memorize these. You can use your notes on your tests and your homework. So have this out as a good reference point. Your homework will also be a good reference point. You're just going to identify all these things and making sure you're identifying them correctly. All right, good job.